So my name is Olmo Maldonado. I have ridiculous amount of time programming. You can pretty much name the language, and I have some experience in it. I have more experience in like JavaScript and PHP, but just ask me something and I'll probably have an answer for you. Uh, I have a master's degree from electrical engineering, so I like the working with my hands and creating stuff. And I'm one of the founders for Tech Tuesdays and Code RGB, and as you all have figured out, this is a community event, and we do everything together. If you want to get involved in some way, that means evangelizing, just letting people know what we're doing, that's good enough. We'd love to have that. I'm a Mood Tools developer. Anybody know what that is? All right, yeah. All right, cool. Mood Tools used to be the shit. Like it was competing against jQuery like left and right. And if you search my name on Google, you can find me like dissing the jQuery founder. It's a bunch of fun stuff. Like at some point I was at AOL and there's like, aren't you that guy? I'm like, yeah, I was that guy that talked shit about jQuery publicly. If you need to reach out to me or you just want to add me, you can just do Facebook / or Twitter / and KitButHub / IB Olmo. If you don't know what IB, it's not like I'm an idiot at spelling. It's just International Baccalaureate. So I picked that name during high school. So let's get started. What is version control? And I want to start with that question because we're talking about Git and GitHub. And Git in particular is about version control, controlling multiple versions at one time. And I'm sure everybody has used undo key, right? Like Control Z, right? That's the invention of that. That guy must have made millions, right? And we also do something crazy like copy and paste because we want to keep two versions because we don't know which one's going to succeed, right? We share it with somebody by email. And you can see on the bottom over here, for these guys that can't see, the undo key is basically you have the starting point and then it goes up the next version, next version, next version, and the program keeps the state or memory of all the different things and it goes back and back and back up to a certain point, right? When you copy files, this is basically what it looks like. You have one version and you create two copies, and you can create two different versions of the copy. Like you have two different paths going away from each other. Sometimes you can get them together again, but it takes a lot of work. Am I right? Like you email something, and is that the latest version, or is that the version that shouldn't be on the internet, right? So you have those issues. If you can close the door real quick. Oh, okay. And so we're basically talking about it. What is the complexities in version control? And the number one of them is, I think, retaining a lot of history, because files get big really easily. And then especially is working with others. You really can't figure out a way to work with somebody else unless you have something in the middle, right? So this is what Git is really good at and strong at doing. And the third part, we're not going to touch too much part today, but I just wanted to hint to you that you can do crazy stuff with Git. Just to throw words at you so you can be like, ooh, ah. You can do rebasing, and you can do shaping of the history, so you can do whatever you want with it, make it look like however you want. Anyway, for A, we already talked about it, but the only thing that I'm adding to it is that V to the N. You can have as many as possible, I mean, theoretically. And the other thing is, if you share something with Bob and you want to merge it back to the original file, how do you exactly do that in a nice, clean way? And then how do you look out for conflicts, right? Like, Bob wrote this, I wrote this, which one goes into the file? And the last one is, if you move things around in the tree, how do you retain work that you already done, right? So to give it more like a concrete look at it, you already know about Photoshop and its undo function, right? Well, Photoshop sucks because you can only do about 25 or 50 history callbacks. And if you do something and then you redo something else, you can't like flip around between different versions of it, right? And then Time Machine, well, it's very linear in how it works. And when you want to have power, like this is an example of like when you're working with a designer and you're working with a client. And I don't know about you guys, but I really love my clients. Sarcasm. They say one thing, and then tomorrow they say another, and then the day after that they say another, right? So Git and version control will save your life, at least reduce the burdens that you have in what you're doing. In this example, I'm showing you that the client might have wanted the second column to be split, and then he's like, oh, you know what, I wanted the first one, and then never mind, I wanted the purple. So with version control, and in particular Git, when you're programming in particular, you can get away with a lot of things when reducing the complexity and getting back to the state that you want it to be in. And in particular, what I love about version control is blame. You can find out why somebody decided to do something. If you can't really see, this is railroad tracks next to like a patio. It's like, who designed that? Why did they design that? And in normal day life, you get away with it because there's no going back to it. Like, was it Joe? Was it Bob? Who knows? But with programming and version control, you know who exactly did it, and you can ask them directly why you did it. And this is the part where business people should come in. You can find out whether an employee is doing really well. Like, are they programming at a certain frequency? Are they on time during the day when they get on and start programming? Do they commit as often as they should? Is something personally going on there? There's actually more and more, like this is called Git Inspector on the left side. It'll tell you which person in your employee list is actually being very performant. At Google, we had that. In a way, we give out awards for people that were performant. And you can do this online already with GitHub. So, that's a heads up that you don't have to have proprietary systems. You can just do it already. And I love the independence. In particular, I can work with something that Facebook released, and I don't care what they do with it. I already have a copy of it. I can do whatever I want with it. And if the community decides that what I'm doing with it is better than what they're doing, then people start adopting it. So for example, Jasmine is a library that was released a long time ago, and JSTD, JavaScript testing driver, I forget exactly, I merged them together. And this adapter became really popular on the internet. And those people that are under my name, they're contributing to what I was doing. And I didn't have to invite them, get them involved, because GitHub is awesome, and people search for the same projects all the time. And if you notice, this one, I guess you can kind of see, he has 1, 2, 3, 4, 5, 6, 7 commits ahead of me. And that's fine. That's the beauty of open source world, is that people can contribute back. If I ever decide to do it, I can go in there and I can merge back a lot of the stuff that he did without having to bother him about it. So anyway, independence. And this is my selling point. Who should be using version control? Everybody. There's really no reason why not. In particular, I would love it if we created an application on medical side. That imagine from the day you were born, you have this history and this tree of like different treatments you've been trying and different stages in life. You can go back and you can replay. That's one of the cool things about Git, is you can actually replay the steps as you're going along with it. So medical in particular, I would love it if we had something there. Architecture, again, multiple designers. What if you did a house collaboratively between different nonprofits, architects, rather than like one chef in the table or whatever? Graphic designers, we already talked. Accounting, auditing. You can actually find out who entered what, why they entered it something, when did they enter it, was it malicious, etc. Software development, we know, and government. I had talked about it a little bit before, but I would love it if I can know who was involved in the bill, what exactly changed in the bill, because they usually submit bills in the long form, the 500 page. But if you just look at the difference between the original submitted and the new one, it was just a couple of lines that they changed. So again, bottom line, anybody and everyone should get involved. And in particular, if you're curious about the Congress stuff, you can actually go into github.com/United States/Congress, and you can find out already which bills are being changed on a daily basis. It's kind of cool. So the nitty-gritty, what is Git? Unfortunately, I'm not going to give you the technical explanation of what it is. This is the fundamentals course. I don't expect the audience to be really prepared to hear object-oriented and its hashing functions and it's deterministic. Not going to happen. What I want you to know out of this conversation is that it's the most adopted in the world. It's extremely fast compared to other ones like SVN, CVS, and in my opinion, it's simpler than other previous arts. There's people, fans from different ones that would say otherwise, but hopefully today I can argue that it's simple. And you don't need any kind of service to get involved with it. The other ones you typically need a hosted. And in Git, you can just do everything locally, which you'll see that about 80% of the presentation today is all local. I really don't need the internet. So to give you proof that Git is so popular, the blue line is Git, and everything else is on a downtrend. So this is active searches through Google, so you can tell that people are interested or not in it. And what is GitHub? It's a hosted service on top of Git, right? And it simplifies collaboration, and simplifies workflows. And sometimes it doesn't simplify, it actually constricts you in a certain way, but in a way, it's a good thing. It's the most popular. It's used by pretty much all Fortune 500, even GE, I found out earlier. And it's totally free for open source projects, so you have no cost to get started. And they have reasonable costs if you want to keep something private, which I discourage you from doing, unless it's increasingly important that you do. And again, GitHub trends versus the rest of the world, like SourceForge and Bitbucket. GitHub is on the uptrend and everybody else is on the downtrend. So what both of these trends should do is argue to you guys, should I learn GitHub or should I learn Git? Yes. It's one of those things in your tool shed that you should just keep. Okay? So warning, we're going to get started on actual coding and getting on some stuff and like the nitty-gritty of things. So I was hoping Renee would be out here. He would get a crack out of this thing. He says it all the time, hold on to your butts, but here we go. So what we're going to talk about on Git and GitHub, I basically want to work with your workflows, because I'm not going to talk to you about the underlying systems under it. I just want you to understand what it takes to go through and actually use the system. So to find projects, you use obviously keywords and search terms on GitHub. And you just go to github.com/search, and you can search already. But there's other wonderful things that are on GitHub. You can just go to github.com/explore, and you can find popular and trending projects. And I use it all the time. I mean, Justin beats me outright, but I find out all the cool programming languages, all the cool projects like Laravel. I had known about it since before Justin, but because of this feature. So I encourage you to use it. I love the bookmarks feature, the stars. I can follow people, and what I love about following people is that I can see what they're doing, and I can learn from them without them trying to have me learn from them. I don't know. Anyway, this is an example of a search for 3D. And obviously you'll look for the terms 3D, but what I love about it is you can search for code. Sometimes when I'm debugging something from another person and I don't have this original source code and I don't have the history, I can just grab a certain line of code that looks very unique compared to the rest of it, and I can put it in the search, and I can almost always find like somebody that is hosting some history of it. So I can see maybe where it went along. So again, I like the code one. Some people don't use it as much, but the users I love, because I always want to find people locally. So I'll show you an example of that soon. And in particular in the stored options, I love the stars. It goes back to the bookmarking, liking kind of thing. And yes, you can finally do also with different languages. And I always want you guys to evaluate the projects. There's a bunch of them. I don't want to say a certain number, but it's ridiculous the number of them are. But the best way that you can know whether it's a good project is just by looking at the code. I think he said it right, is that I don't care about your background. Like, show me in code that you're the shit, right? So what you can see here when you click on the graphs is you can see the code frequency. How often are they entering code and are they iterating? The punch card, like, are they Eastern time, Western time? Are they in Europe? You can see how often they're up all night, and you can work with them. And just this trend has to be either consistent or there's no like big dips over here. This might be a little discouraging, but what's cool is that somebody took over afterwards. So just gives you an idea of all the power that is involved here. And you can search for people. You can search by first name basis, because on my profile I do first name and last name. I get recruited all the time from random people because I have my information public, but I don't care. The follow button, just click on it. I guarantee you're not gonna, nothing bad's gonna happen. And when you follow me, you're gonna see basically the things on the right. You're gonna see what I starred, what I commented on, and there were other things that you can find, but you can also see my contributors and also my repos that I work with. In particular, you can see the things that I've starred. So when you click on that, you can see everything that I've starred. And I don't star indiscriminately. I star very discriminately. So I encourage you to look at stuff that I've starred because it's kind of cool. And also organizations. Am I involved with a lot of multiple things? I guarantee you there are people that are just as crazy or crazier than I am, having like 6 or more organizations. So go through the organization, find who works at the organization, clicks on each of those and follow them. Like you can go to Facebook and you can get to all their developers and you follow them. Right now I'm watching the Facebook React conference on YouTube every day. So anyway, you're encouraged to follow, you're encouraged to star, watch the projects, get notifications on the issues. So in particular, I want to slow down and talk about that, the watch. When you watch a project and you're comparing stars versus watch, I like to see more watches than stars, although it usually never happens. But if you have like 200 watches, then that's ridiculous. Because you're going to get notified on issues, which is like tasks, like something wrong with the bugs, etc. Or you have pull requests, which I'll talk about in a bit. And you can see what they're committing as it's happening. So if you put a watch, you're going to get all this activity coming down to your email. And so usually people don't do that. So I love watching certain projects because they do crazy work. And it's always encouraging to see what they're doing. And I learn so much just by going through it. So you can tell I don't watch a lot of TV, I guess. So now let's get down to it, okay? So we're going to create a project, and we're going to talk about uploading it and putting it out into the world, okay? So again, I'm not going to go over certain things, and one of them is how to set up Git, because if you just go to that article, it'll tell you how to set it up on Windows, Linux, Mac. I don't know if there's anything else. And you have two options as far as GitHub authentication. You have the HTTPS or SSH. And if you're not familiar with the terms, you just go to the page and just do the recommended, which is the HTTPS. And basically, once you do these things, you can do all the things that I'm doing. And we'll go from there, okay? Is everybody okay so far? Am I going too fast? Do I need to slow down? We're good? All right. So to create a new repository, does anybody know what that is, repository? A container, basically. A container of all the history and all the code things. Sometimes I might like jump on keywords because it's so comfortable to me, but if it's anything that I say doesn't stand out, like it's not clear, just raise your hand. Like this is supposed to be like a community discussion kind of thing, so don't feel it has to be formal education. I'm going to throw the eraser at you or something. So when you create the project, just set a name and a description. I mean, it's simple as that. And what I want to point out of this form that they have is the public. If you're unpaid, like if you're just free, then that's when it's going to be selected. And then private, you get to decide whether you're going to pay or not. But like I said, usually you don't have to pay. I mean, it's most things that you do online. I mean, you keep it public. I love to initialize everything with this thing, because it saves me a couple of typings, right? So I just selected, and the git ignore, if you're not familiar what it is just picture that this program, we're going to talk about it, this program just takes whatever you have in there and it assumes it's important. So if you don't ignore certain things, then you're just going to be included in there. So if you have like a trash bin inside, stuff like that will be automatically included. So you want to, the git ignore, it has certain options like Max and for .NET, you just select that project and it'll fill the list of the ignore automatically for you. So I don't use it as often, but some of you guys in your different projects and your different environments, you might want to use it. And the add license, I just use MIT, but if you're not familiar, each project should explain publicly to the world what is the requirements. Do you need attribution? Do you need to be told when you're going to use it commercially? If you're going to use it commercially, I need to charge you. So it is an important task as well to decide what kind of license you're going to use. And again, I leave it to you to look up each one. I personally just use MIT, which just says it's free. You don't have to bother contacting me, attribution to me, have at it. So I know some people are like going like, are you crazy? But so I created it. As you can see, this is the result of it. What happens is it creates this is the repository the way it looks. And what's important out of all of this is it. This is the clone URL. This is how you access your repository on GitHub. So you remember I mentioned you have two options, HTTPS and SSH. This is where you decide what you're gonna, whatever you picked. This is where you decide, HTTP or SSH, right? So you just have to make sure you're using the right one. Otherwise, you skip the step kind of thing. And this is just a hint that there is actually software to reduce the complexity that I'm going to talk about right now. Some people might say I should talk about the easy part and then the hard part, but this is fundamentals, right? Get you guys excited about getting involved. And this is an aside, but you don't need GitHub. You really don't. It's kind of small, and you can see this online. Let me see if I can zoom in somehow. So, nope, wrong thing. Sorry. Okay, so I thought I was going to be able to zoom in, but it's okay. Basically, all I'm doing is, no, that's it, I think. All I was doing is showing you that you can just do git init, like initialize init, and which is right here. So I make a folder, I change to that folder, I move to that folder, and I just do git init, and I have a repo. In other software, you have to do a dedicated server, you have to do configurations. What the beauty of Git is that you just initialize it, and you can get started doing what I'm going to show you right now. So what I'm going to do is I'm going to go over a lot of terms from Git, and again, I'm going to discuss them during the demo, and I put some slides like this. It's not for you guys to read, but it's more for you guys to, like when you go back home and you're like, oh, I forgot about this. So you guys have reference of where I'm at, okay? So I'll just skip over this. And again, I'm not going to go through this because I'm going to do it in the demo, but it's here for you guys as reference. You don't have to go through the whole shebang. So you remember that URL git clone. So we're going to do it right now. And usually in demos, everything breaks apart, but we'll see how this goes. So is that clear? Can you guys see? And I'm going to borrow this real quick. Okay, so I need the URL. So I'm going to go back, go to GitHub, or I can just do it off of the slides. So I'm just, like I said, you can just copy it. You have access to the slides on your computer. So just copy this, and so git clone, put it in, enter it, and it's cloning the repository. So that means it's downloading things from the internet and putting it on your local computer. So if I look for the folder, it's there. So I go into the folder, and I see what's inside. And I have that license file that I created, when I created the repository, the project on GitHub. And I have that README file, which is just a standard file. It's not a doc or like Excel sheet that the ones you're typical of. This is a markdown file and an MD file. Again, don't worry about any of those information. It's just be surprised that, oh, it downloaded everything like it should be. And right now, one of the first things I want you to do is git status. And this status, it tells you at this moment in time, where are we at? And it tells you we're on branch master, which is right here. We are up to date with the origin master. Origin is the remote, the access point to what we're talking about. And there's nothing to commit, and we have a working directory, like a clean directory. So we're clean. So at this point in time, you can actually start working. This is where you do whatever your business is. So right now I'm just going to echo hello world into the README. So if you're not familiar, echo is print out, and greater than means append to the file. This is a Linux thing. If you're on Windows, does PowerShell have any of this? Okay, so you can realize it. So I do again git status. And now things have changed. Git is telling me, oh, I noticed that your README file is modified. What do you want to do with it? So you can actually the status menu gives you already a lot of heads up on what you can do with it. I want to save that file. So maybe I should explain a little bit on how that works. I can open it real quick. I can open the README in an editor. This is called Vim, but again, don't worry about that. And I can do whatever I want with it. And I can save it. That's wdo for write, written, and then quit for getting rid of it. And again, all it's telling me that it's modified. So Git, the only thing Git does is it tells you something is different here. What do you want to do with it? Do you want to stage it? So it's one of those jargons. Stage it. It just means that I could have multiple files. So let me add another one. Touch means create file, and then another file. Again, it's arbitrary. And Git will again say, well, first of all, the one file that I do track, that I know of inside of my repository, it's not staged. Like if I was to try to commit, which is one of those other words, it wouldn't be included. So I mean, I can just show you, commit, and there's no changes to commit. Is everybody like following along why they're being so hypercritical? Like why they don't want to do this? Why nothing is happening when I do git commit?
The changes have to be tracked in order to, because any small change would be significant.
Exactly. Especially Git was designed for programmers, but imagine in like a program that you need to install and you want to save it into a repository. If one byte or one bit changes, it messes up everything. It could potentially mess up everything. So I'm just showing you here that just by doing git status, you can find out which files are being tracked, which files are not staged. So to stage a file, to make sure that the next time I want to commit or create a snapshot of the current setup of my repository, I needed to do, add the README. So now that I do the status, now it's telling me, okay, changes that will be committed will be the README file. And the untracked file, the another file, I'm not going to mess with it. I'm just going to leave it alone because you're telling me not to include it. So right now, if I do git commit, and it's telling me, okay, changes to be committed will be the README, and the untracked files will be the another file. I just leave it alone.
Kind of like when in my desk, remember on my desk I can have envelopes. Yeah. The mailman is going to come in and they can see the envelopes, but they're not going to touch them unless they go to the box where it says, these are the ones that I want you to pay. Yes. So while there's all these envelopes, the guy knows that only the ones that are in the box are the ones he's going to pay. So they will be the ones committed.
Exactly. Good analogy. Yeah.
So right now, this is what's going on is that when I commit, I create a snapshot of the whole thing. I'll show you some more examples of how, like, what do you mean the whole thing? Like, yeah, literally everything that is tracked will appear the way it is tracked. It's like literally taking a picture of the files, okay? So right now, what it's showing me is to enter like a message. So I'm just going to say, added one line to the end of the file. And there are guides on how to best write this, but let's just keep it simple. And I just did write quit. And so I did a commit. And it says master some kind of gibberish that's called a hashtag, or the hash value for this snapshot, for this picture. And it shows the message that I put in there. And it's telling me also data of like how many files were changed and the number of insertions. There's a utility function called git log that will tell you all the things that have happened to that repository. So at the very beginning, when I created the repository, there's the initial commit. When I added one line, there it is. And it keeps track of the time. So you can tell that I procrastinated for this presentation. But is everybody clear on the fact that Git, you need to tell it what it needs to track, what it needs to commit on the snapshot? The snapshot needs to be like committed and added. Is all those terms clear? Anybody lost so far, or we're good? Because this is pretty much it. Like really, the rest of the talk is going to be branches and it's going to be remote work. So if you can get this just by itself, then already on your computer you can already start protecting your files. You can protect your history without knowing anything else. So if you can get this, you already know Git. So many gits. Anyway, yes?
So, if I understand correctly, every single time that you commit, you take a snapshot.
Snapshot,
of
yeah.
what you wrote. But most of the time when I go grab a function or something and then I try to kind of modify it to fit my needs.
Yeah.
What time am I supposed to commit? Every single time I can make a change, or?
Yeah, good question. What,
Reasonably, I commit every 20 lines that I have changed, or when I created a new feature, like when I try something new. So if I was writing code and I needed to test a certain function, I would commit the moment that I create the function that I need to test, and then I would commit the moment that I figure out that the tests work, and then I would commit it. You don't lose anything by committing. And let me show you the following. So open-a is a Mac thing. It basically says open application. And I'm going to launch this application, which you can download totally free. It's called GitX. The equivalent in Linux is GitK. And I'm going to show you this local repo. So, you know, you had the question of like, when do I commit, and do I need to worry about how often? Not at all. This software, including GitHub, this is why they're, you know, you can do things locally and you can do these things at GitHub. And locally, you can just look at the setup that you currently have. If you notice that git log, it's pretty much the same thing here, right? It's telling you the exact same things. But the beauty of this project is it'll actually tell you what was been added. So the initial commit, you can see the license was added and the README was licensed, so it was added. And you can see things in nice colors and figure out how things are done. And so this is the only thing that I added to it. So it's really a personal choice as well as the team. I prefer when my team does a lot of commits. And when we get to the branches, you'll see why that's even better. Because if you submit a commit that is like 50 or more lines, does anybody do any like reviews of code, like from people that they work with? All right. Do you like it when they send you like 100+ lines of code to review? Right. So it's at Google, it's one of those understood terms that if you submit something above 100 lines of code, expect that it won't be reviewed that day. It'll take the whole day next after that. So this is like a software development thing, but just be reasonable, right? Do it more often than you think, I would say.
I think even in the branches, you want to keep them clean. I mean, after you don't want to have that many branches after you have merged them.
Yeah, delete the branches. Yeah, I go over that too. So let me just go over the presentation, git log, git commit, git k, and let's push this. So git push is the command that tells Git take the snapshots that I've already collected locally, right? Because if I compare, I'm getting a little ahead, but if remote show origin, so this is telling me that this will do a fast forward. So again, I don't want to go into that detail, I guess, but I can do the following: git diff. It's one of those wonderful commands, origin and master, and the git diff will literally take any branch, and we'll get to it, and any repository that you give it, and it'll figure out what is the difference between the two snapshots, or all the changes that you've done to it, not necessarily just one-to-one. Git is extremely powerful, and really I'm not doing it just as doing the fundamentals, but at the same time, I think it's just enough so you guys can just like, okay, I gotta learn more. So anyway, so let's push this, because this is telling me git diff that the origin doesn't have that information, and I can double check it by reviewing the status, and it says your branch is ahead of the origin master by 1 commit. So obviously the GitHub repo is out of date, right? Like some things are missing. So if I do git push origin master, I'm telling it which remote and which branch that I'm going to push it to, and I just push it and it goes out to the internet. Oh man. So this, I made the mistake of, let me ignore this or watch it. I did make the mistake. I use SSH because it's one of those older things, and it's on my IB Olmo. Getting started. So if it's not clear, I had the wrong configuration for the remote. So I just remove it. They're just labels. So right now, if I do git remote, there's nothing that shows up. I'm working locally. And I can still do echo something else on my README, and I need to add it, so I add the README, and I commit. And this is a shorthand version of adding a message. You don't have to go in through that whole thing. And add a message and status. I'm good, so I'm gonna. Oh yeah, I need to. So anyway, I just showed you that I'm still working with Git without actually having connections to GitHub. This is all local. And I'm getting the SSH key of the remote origin, and there you go. So I just take the URL and I define the remote that I'm interested in, right? I'll show you that more in detail in a bit. And I just git push the origin master. So this goes out to the internet and rejected locally because it contains the work that you not locally. Oh. Why? Oh, this thing, I think. Updates. No contains. Oh. Git pull origin master. Okay. I guess we're jumping a little ahead. So what I found out is that when I did the demo, I had already pushed some things to the internet. So let me show you what I'm talking about, because I can show you that in the presentation. So we talked a little bit about master and branches, right? I know it was brought up. So when you start your repo, you start on the master branch typically. And master is just a label. You can change it to neutron, I don't know, whatever you want. It doesn't matter. It's just a label for you to keep track of where you're at in the tree of code. You usually don't want to have too many branches all over the place because of that. You want to follow one deterministic path to pointing everything together. So in this example, I'm showing you the following. You can have as many as you want, but just try to merge them as much as you can. And in this situation that happened that showed that a little conflict, I have a situation where I had already committed some changes ahead of the time, and I already published them inside the master. So I already have some things that I should have grabbed from locally, but I didn't. So what happened is I tried to pull I tried to download from the repository, and it was telling me, well, what do you want to keep? So that was one example that I was going to show, that I was going to break things, and there I'm showing how I'm making a new branch. So let me show you what the branch does right now. So when you press on branch, git branch, it's telling you that you are currently on master, right? So let me see what the origin has. Oh, I see what's going on. So, show origin. So you can see immediately what I was doing wrong. Here I'm supposed to be working with GitHub demo, and I have a getting started. I jumped ahead to the wrong repo, and I'm grabbing two different contents. So I basically ended up with taking two different repositories and mixing them together by mistake. They both have README files inside of the repositories. So Git is like, what are you doing? Like, I can't work with merging this together. So if you go into README, which I think is the one that is broken, you have all these things. I'm kind of jumping ahead in the discussion, but whatever. We might as well learn by debugging, right? So I took two repositories and I merged them by mistake, but if you notice, it's still recoverable. I can go back to the state that I was in. It's telling me that here's what I have in the current head, which is, remember, I put something else, and it's telling me that you have the following on the other repository, on the other changes. Which one do you want to keep? because I don't know what to do with it. You need to tell me. And then this is other things. Let me see if there's other examples of it. Yeah. Yep, go ahead.
Credit card processing, what is that? It said Stripe credit card
Yeah,
processing.
this one? Yep.
Yeah, is that part of that or?
Oh, well, it's because it's two files. See, what happened is I mistakenly took the wrong container, the wrong repo with all the history, and Git doesn't know that you made a mistake. It just did what you told it to do, right? So what it did, it tried to take both files and put them together, because when you're developing software, you're mixing them. Yeah, like you can actually do a branch for a feature, say add a window to the house, and you're working on that window, and then when you're ready, you add it to the house. You merge it back in. Well, I can still work on the house as I'm developing the window. Nothing precludes me from doing it. And when I merge it back, I just have to make sure that wherever I'm going to merge that window into the house, I don't have anything else that might break it. And right now, this is what happens: is that I took two files that weren't at all coherent, right? And they weren't at all in the same history, and in their own history of versions, and I just meshed them together. So I'll show you how I can clean this up quickly, and I still retain both information without losing anything. But you had a question.
I was just going to ask about the cleaning up redundant data.
Yeah.
Yeah, I was just trying to figure out what you're doing.
Right now, I was just trying to. Yeah, right now I'm just trying to figure out what exactly happened, and I figured it out. I grabbed the wrong repository, and I mixed them together. So what I'll do is the following: is I'll just quit this. I can see that I've taken the wrong thing, so I can just reset hard. So that's it. I've just reset where I was before. So my repository right now has a clean history. So if I go into README, it has what I had before. So again, that's the power of Git. I didn't have to call anybody up. It's like, oh shit, what did I just do? I know the history is maintained. That it's not gonna like ruin all the work that I did. And the other repository is fine on the internet as well. So to actually do what I wanted to do is I need to go to, I'm gonna grab this thing, but instead of, okay, so here's the actual one that I needed. Because if you notice, if I do git remote show origin, it says getting started, which I want the GitHub demo one. So all I have to do is git remote remove rm remove origin, and then git remote at origin, and now git remote show origin. Again, origin is just a name. It's one of those slides that I was going to talk about, and it has the right one. So now when I push to the origin, the changes, there you go. What this is telling me is the online repository went from this version, this hashtag or this thing, into a different one. So it moved it forward, and you can see the difference, right? Like if you go online to GitHub, this is the GitHub demo. The initial commit that I committed was only 12 hours ago, and when I refresh it, it says 9 minutes ago. So by Git pushing, everything is live. Everybody sees it, that it's on there. Okay? Now we can go back to the slides. It's like the demo gods. You never know when they're going to come up and bite you. So did I lose anybody with all that mess that ended up happening? Are we still good? All right. So working with branches is really simple as well, although I know what just happened wasn't so simple, I guess. But you have a function called get branch, and you primarily use that as well with the get checkout. Don't ask me why they make you do get checkout -b to make a new branch. Like you would think they would do get branch -n, but whatever. I mean, they don't. And what I'm going to show you basically is I want to show you how this looks like here, right? I want to create a branch from this point in time this one, and move outwards, right? I want to take the current snapshot and just copy it over in software terms and work with it. So I'm going to take this, and then I'm going to do checkout. Well, first let me show you what branch I'm in, which is master. So I'm going to do checkout B, so create a new branch. So I'm going to do a new branch. And now I've switched to a new branch. It still has the same snapshot, the same information as before, but now Git knows that you're working on a new window, a new section, yeah, a new track. So now if I do any changes, so again, I'm going to echo hello from Texas, I don't know, whatever, to the README. And again, I see that. You see how you repeatedly do git add, git commit, git status, just to be sane. So you just do git add, readme, and then git commit. Add a Texas message, and now clean. Well, let me remove this thing because we don't need it in terms of the purposes. So now we have a clean version of the repository, and if you look at the history, it kind of looks like it's like vertically connected to each other, because in a way Git doesn't discern, well, what's different about the track that you're doing. You just labeled it differently. So if I go to the master, the other branch, so check out master, and I do echo another message to the README, and I do a quick shortcut, and it says another darn message. And now if I do, there you go. So is everybody can see that? So at this point in time, I told Git, pull me over to, just to let you know, this is a new track. This is a new history that I'm trying to do. So just keep an eye on it. And before I added another message to the master, Git was like, well, there's really no difference as far as history from what you're doing. So I'm just going to keep showing you the same one. But the moment that I added another change, right, to the history, then it understood, okay, you do have two different versions between the two. This is a real branch. It literally is a branch. You can see the fork right there, like of a tree. Go for it. Unlimited, really, yeah. It's ridiculous. But it's like Robert said, do you really want to have 5 branches? You sometimes get that way because on your repository, you add more remotes, like more people that you're contributing with. So you might have like 5 team members. And each team member, if you're following their branches, because you can decide not to, you can see where they're at relative to where you're at. So sometimes this gets a little crazy. But it's with practice, right? You can decide. But normally when you're just working by yourself, which I think 98% of us here, we do that. And those of us that are working in team, we've already known how to work with this. So,
if you think of branches, if you use something like Photoshop, so let's say we're going to work on a painting, and I give you just the beach, and then I assign, let's say we're going to have 4 branches, and I assign a person the sunset, another person a ship on the ocean. So those would be branches. And you take the Photoshop from there, and you're going to be working on your branch. Let's say you have the sunset, and you're painting it, whatever. Of course, you took the beach, so now you have the beach and your sunset. And if you finish before anybody else, you can say, I want to commit that, and you push it in, and whoever's working on something else can say, hey, let me see how it looks, see if anybody has changed. And when you do a pull, when you say, let me see, now you can see the latest and you can see the sunset. So it's just layers, like on Photoshop. Everybody's working on their own layer and committing, and then you end up at the end with a final product. But
Composite of everything.
yeah, of everybody else, and you have the original, and you have the commits, so you have all those versions, all those things that you can always say, well, we don't want this one, or I want to go back to over here, how it looked before, and stuff like that.
yeah.
This is kind of like Photoshop.
Yeah, exactly. Yeah, you're really good at those.
Can I ask a question?
So, go for
When it comes to it, like let's say for example I have 5 people. I have the original and then 5 people create a new branch or something like that. Are those literally a full copy? Let's say, like, for example, an application, all files and everything. And then when it gets merged in here, just the differences actually get merged in.
Exactly. No, yeah, Git is really intense. Yeah, it's like I said, I don't give Git justice because if you look under the hood, it's actually quite impressive. There's a lot of projects that actually stemmed out of a lot of the algorithms that Git created. In particular, there's this backup solution where it literally takes your whole system and it does a Git repo on it. So you can have, you won't lose any of your history. It's really intense. But anyway, what I want to show right now is what we already experienced, but in a simpler dynamic, right? I showed you that, I can show it here easily, is that when I created the new branch, and it's in that greenish color, I don't know what it is over there, I only added this 5th line that says, hello from Texas, right? Well, I went back to the master. Let's pretend that this new branch is like Bob or whatever, that he's doing it. And I want to take Bob's work and I want to pull it into my system, like to my current master, my main trunk line. Well, ahead of the time, I could already look at it and say, well, this is going to be an issue, right? Because that 5th line says another message. It doesn't say hello from Texas. So already as humans, we can tell this is going to be a conflict. We need to somehow put them together physically. But usually when you're programming, you don't have to do all this hard work of like investigation ahead of time. You could, but most of the time, I personally just let it happen. If it's going to be a conflict, I just reset like I did, and then I'll just manually work through it and fix it. But let me show you what that merge looks like, because in a way, so there's the git merge. I'm telling it, I'm on the master branch. I'm going to merge that other branch, like I'm trying to pull it literally. And it's telling me conflict content, merge conflict with README. Like we know, it's going to happen. So it's telling you, I can't automatically merge it because Git is actually extremely smart about it. Again, crazy algorithms. You have the same file, you have a change in line 10 and a change in line 20. It'll just mix it. It knows it's okay, no big deal. But in this case, it's the same lines, so it doesn't know what to do. So to fix it, we go into the file. And like I showed you before, we have these less than, and then greater than, and then this in between equals. And it's telling you, locally right now in this branch, you have this message. And then the other one that you wanted to merge has this message. What do you want? So we just get to pick. All we have to do is decide. We just remove, well, we'll just keep both of them, right? Because we want both, Bob's version and your version. So I just remove those extra things that they added, and I save the file. So W for write, Q for quit. And now if you look at the status, again, I love status. I would encourage you to just use it, even though you know what's going to happen. I haven't staged that file. I haven't told Git I'm done with it. So if I try to commit right now, it's not going to do anything. I mean, I think. Let's see.
If multiple conflicts exist, you go through each file.
You go through each file. That's why, again, you don't wait to commit. Right now, I'm showing you a simple merge. What you can do is you can do a merge interactive, which will play back each single commit that you do. And you can see what the changes are and say, oh, I don't want this one, I want this one. Again, more complicated, more advanced, but this is the typical case. You're not going to go through each one, especially like I said, you're working with yourself. You already know, whatever. Like it's no big deal. The conflicts usually happen when you have one branch, you have another branch, and then you do something else over here, and then you're like, oh, I want to do this again. There's a command called git rebase, which I realized I didn't include it in here, but what it does is you branch out in this point and you do something else over here. Well, rather than, and you know that this is independent of this one. So rather than deal with the conflict, what you do is you rebase it. You tell it, instead of connecting off of this point, I want you to connect off of this point. So I don't think any other program does that. It's a Git thing, I think, in my opinion. But what's cool about it is that it'll actually say that in the other one you add one line, it'll replay it as if you did it on top of at the location that you were interested in. It doesn't have to be at the top. You can choose wherever location you want. So again, it's quite impressive what Git can do, but this is the typical thing. You just commit. So I haven't committed it. I haven't told it. By the way, we're good to go. So I'm going to do that. Add the README, and then commit with a message, fix conflict. And then the repository is back to being happy. If you look at the history of Git, it's kind of small, but you can see it right here. It kept both points. It knows that I added Texas on the other one. It knows that I added a darn message or whatever on the other one. And then it knows that I try to fix them. And you can see what it ended up being is I added that other line in line 6. Okay? So again, I'm not giving it justice, all the crazy stuff that Git does, but hopefully this just gives you an idea of the typical case. I really doubt you're going to find yourself conflict this, conflict that. And if you do, you will quickly realize what you're doing, which is basically when you create a branch, you need to work on it. And if you're going to work on another thing over here, you create another branch off of it. You don't add to the master. The master, you leave it alone. You make another branch aside of it, and you keep going up on it. I think I'll do a follow-up on Git on the best practices, but for now, just believe me that you want to keep master as pristine as possible, just to reduce all these conflicts that happens. And this is what you do when you work with somebody: is you tell them the rules. Nobody touches the master unless we go through a pull request. And during a pull request, which we'll talk about, this is dealing with the conflicts. I'm showing you the example now, and we already went through all of it. And we kind of already talked about this as well, where we're talking about working locally, working on the remote side, working with GitHub. And we pretty much did this too, where we're talking about the things we didn't do is you can actually change the name of things. I like to do that. Origin is so abstract. So what I like to do is I like to label by the project or the user. Hey. All right, go for it. Hey, and I'm gonna push, to IB Olmo, the user at GitHub. So it's just easier for me to read and understand what I'm doing. And in particular, like for example, GitHub demo, I can add code RGB. So now it's easy for me to say, oh, git checkout IB Olmo new branch. Like I know where I'm reaching out to and getting it, right? And then, anyway, so is that cool? So in a way, through this mess that we created, I'm kind of showing you what happens here all the time. I know it seems like sometimes you're going to get a lot of conflicts working with people, but just think about the upside, which is you can figure out a way out of that nest, out of that hole that you dug yourself in with all these conflicts. There is a way out. So if you follow this guide, a successful Git branching model, you will reduce these burdens that we felt today about the merging, the conflicting, because you basically keep the GitHub pristine, keep it clean as possible, and each person in different computers in different locations in the world, this is the beauty about GitHub and Git, they can do whatever they want. Like people can work on the yellow or the red or the green or the blue branches, and because of Git and the power of it, and if you go over to the guide, you can learn how to do the merging wisely, and with a nice workflow. Is everybody okay so far? Any other questions? All right. So we've pretty much been talking about ourselves. We're like very narcissistic of us. What we need to start talking about is how do you work with others, with everybody else's code, because you're not going to be using your code all the time. And the term on GitHub is called fork, and that's on Git as well. And if you think about it, what you end up doing is, no, I don't have it. What you end up doing is you create a copy of it, a fork of it, and another branch, if you will. You literally have that same thing with you. And what you're going to end up doing is you're going to work on both, or sometimes just on yours, and then you're going to push things to your repo, and I'll show you that. And then you're going to get the organization to pull, to merge your stuff. Am I okay on that one? So this is like I said, a GitHub term on on just doing that little layer above the whole branching thing. It's all about working with other people. So we'll get to it. I think it might be easier to check it out.
What's the difference between what you just did for your local Git,
Yeah.
the remote, and
There's really nothing. Semantically, it's all about you're doing something with another person's code, but you'll notice here is that to make a fork, a copy of another repository on GitHub, you literally click on fork. You can't really see it there, but you click on fork and you tell it, make sure to put it on under my organization, like my profile. And after you do that, now you have the same repo. So your question was, what's the difference? There's really nothing. Because when you fork, you have no rights to that. Like say I fork Facebook React or Facebook Messenger or something, right? It's not like they're giving me any access to that repository. They're telling me, you're welcome to grab our code. You're welcome to mess with our code. And if you happen to be willing to contribute back, then by all means contribute back. So this is just setting you up so you can do that. And when you fork it, if you notice it has that information, code RGB, getting started. So it has history of like, where are you grabbing this from? And you can see the list of number of forks, that people are forking, keeping copies of. And it's the same thing. It's just a URL that they give you. And this is if you look at it, this is you, right? And this is me, obviously, but this is your profile, right? So when you end up with that, you do the same thing again.
I guess the pool only brings it to your local, and the fork actually puts it already on your GitHub account, right?
So GitHub does all the work for you. I think that's the answer to that question, because when you tell it fork, it does a clone. It clones it locally on their servers, and then it branches it for you, and then it creates a repository for you, and then it pushes it. It does a lot of things in the background, but you end up with your own repository. So you just do the same thing, git clone, and then you go into the folder, and you add whatever you want to do. You add the files that you changed, like we already learned about. You commit the things you changed, and then if you want to check what kind of remotes you have, the typical one that comes out is origin. That's the original name that comes out. So you just push to the origin. And I kind of want to show you quickly what this looks like so you can see that the origin isn't, I remember I grabbed it from code RGB, right, the fork. So I'm going to show you that the remote doesn't say code RGB, it says IB Olmo. So it's one of those, I mean, at least when I was getting started, it wasn't clear to me. So I'm just going to copy this really quickly, go out, and then I'm just going to paste it. So go in, and then get a remote, show origin. And again, I'm working with my profile, with my repository. So this is showing me that I'm this. Yeah, I have no access to that one, right? So this is what you typically do when you're working with somebody online, is that I don't have access to Jaime's computer or his repositories. What I have to do is I have to push it to my repository, to my getting started. So let me search for it real quick. Repos, getting started. So I have to push it to this, and then I need to create a pull request, which I think I have it in slides. We're almost done, guys. Which I have in slides. Which is why I didn't want to redo the demo, because it's something we've already seen. So once you push it to your repository, then you go into your repository and you compare. That's the button, the compare button. You compare the current state that your repository is with the other persons or multiple persons. That's the crazy part of this thing. You can actually select here if you want to work with code RGB or you want to work with another fork of another person that has the fork. Sounds weird, but yeah. I've done it before where I have, like, say, Intel or whatever, like the repository that I'm working in. I have no access to it, but I can work with 2 or 3 team members in different places, and we can create, where we want to get to, and then eventually we just send one whole thing to Intel, and so they can use it. So we're not dependent on Intel or like blocked by Intel. We just work on our own, right? So the fact that I'm creating a pull request here is just me contributing back to the original repository. And I'm telling it, I need to put it to the master and to the master branches, the two locations that I'm interested in. And then I'm going to create the pull request. And this is also important. What am I including in the pull request? What is the changes? You have to realize that it's so easy to ignore this fact, but sometimes you're going to pull in 1,000 or so files because you had no idea you were including some different things. So just things you would watch out for. And when you click on create the pull request, it's just like any other thing. You just put the title of the description of what you're doing and a little bit of comments, and this is the money maker. If we can get a green sign, then typically they'll review it and they're like, okay, it's within 50 lines of code. I know that this is not going to break stuff. And all they have to do is go into their repo. They look at all the listings that there is. This is the pull request icon. And it just gives you a list of all of them. And this is from the perspective of Intel, of Facebook, etc. They're going to see this. They're going to see that I didn't put a description, but I'm including a commit. And if they were to click on it, they would see that I only added a line. And they have the ability to just press merge it. So within a couple of minutes, I potentially just contributed to a multi-million-dollar conglomerate, blah, 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 like people, like Facebook right now. If you go to Facebook like repo and contribute back to React, I mean, your code is just used by millions of people out there. And this is what it will look like after people have pulled your request. It shows that, well, this is me again, obviously, but I merged it literally from to the CodeRGB one from mine. So if you go to the history of CodeRGB, it will always say my name. So you know how sometimes Adobe, when it launches, it shows all those authors? You can find my friend's name in there because he just added one little thing. So it's kind of cool, right? Like you don't have to do much on legwork. You just have to fix bugs or two. Because I didn't go much into that detail, but if you click on this guy into any of the popular projects that you're interested in, you're going to find hundreds of bugs. And if you fix one bug, you're going to go into their lifetime, and then you're going to be remembered by the gigabytes gods or whatever. I don't know, which I think is awesome. That's just me though. So you saw the terminal. I was messing with the command prompt. You don't have to. You can use the Mac OS or the Windows. I'm not hurting on anybody. And it pretty much does what that getX does, but with like some more pretty icons and then syncing and reverting and simple stuff. No more typing it in. So if you're just getting started and you just want to get started with GitHub or like Git, or you want to work with your teammates at work and you want to like, hey, let's start working with Git, or at least let's mess with it, you can get them to get started on this one. And hopefully with the lecture of today on how things work in the background, and then the jargon in particular of like why checkout, why commit, what's a snapshot, what's going on here. Hopefully this gives you like a leg up versus just doing it on your own, which is what we're trying to do here. If you would be so kind, and if you're interested, if you really want to practice it, I encourage you is just fork the getting started. If you notice, we had stuff about Stripe and different things. Why don't you add Coursera courses that you like or something, and send me a pull request. All right, send me a pull request, and you're done. You just did what we went through today. And I know it seems like weird that I would say that, but that's really it. 90% of the time, you're pretty much just going to do that. You're going to pull, you're going to clone, you're going to do your changes, you're going to push to yours, you're going to do a pull request, and that's it. Sometimes, like after that, you just go to yours, you pull from the main repository the changes that have happened in the world, whatever, and you're refreshing it basically. That's that icon, and you just add your changes, do a pull request, and you add it. It's an iterative thing. It's very determined. And that's it. Thank you so much. I have some evaluations up here. I'm going to pass these out for anybody who doesn't have laptops or anything with them. And I do have some pencils. But I'm willing to take any questions if anybody has some. I know we kind of did a like interactive session, so if you don't have some, that's cool with me too. But any questions? Okay, go for it.
You talked about GitHub as far as like trying to get your work published
in a place where other people that are interested in programming, as in somebody that would want it as a career, to post it on there to get a job? Is that what you're saying? Or to
Yeah, that's how I landed Google actually. They didn't ask me about UCLA. They didn't ask me about any of that. They just wanted to know about MooTools, and they were like, I see that you're on GitHub. You know, like it's crazy to believe, but like I know the right hand man of like Facebook because of GitHub. Like we work together online. That's like no big deal. For the JavaScript group is Tom Ochino or Okino or whatever. I don't know how to say his last name, but yeah, he and I used to work at MooTools basically. It's this online place or whatever. So we worked together online, and he was in Buffalo, New York. Buffalo, whatever. Yeah. So we just work remotely. I work with people from Japan, from France, Italy rather. What was that?
So I guess it's similar to like an open ERP system, but for programming. Enterprise resource planning.
It's not a resource planning because it doesn't have like tasks, and you can add tasks by doing the Git issues, but you know it's not very.
You said that there was like monitoring for programmers and stuff.
Yeah, I would say from the spectrum of like ERP and just like a repository like hosting, it's like in between. It has both features in there. Yeah, you can do it. Yeah. My team, like with MooTools, we use it to keep track of issues and milestones, and we set up a milestone with all the issues that we want to accomplish. So in a way, it is ERP because we want to accomplish that milestone.
That's basic project management, I guess.
Yeah, exactly. Yeah, it's fine. But yeah, I haven't. It has a slow start on Git and GitHub, but once you get it, it's so repetitive. It's those edge cases that sometimes slow you down, but they're also so interesting as well. Like, why did it happen? How did we get to this point? But it's very rare that occurs. The benefits outweigh the difficulties, I guess, that you might have at the beginning. All right. Well, there's still food, hopefully, and should be some drinks out there. We're going to hang out still. I'll be up here if you have any additional questions. If I could have you as well, go to codergv.com/academy/vote. I would love it if you would tell us what's the next class that you want. And if you're interested in presenting whatever you want to present, then you're also welcome to lecture and teach us something. So, cool. Thanks.